friends, today we are going to discuss about the second order system in control system. So in my previous video I have described the first order system that will help you to understand the second order system. If you did not watch that video, I am giving the link in the description. You can check that video out first, then can come for the second order system. So today let us start with the second order system. You first always have to remember the basic transfer function of a second order system. Now the transfer function of second order system is, if the output is Cs and the input is Rs, then the transfer function is omega n whole square by s square plus 2 zeta omega n s plus omega n square. Now in some books or some teachers can teach this zeta as rho. Both the things are same. So now how does it come? This actually comes from this block diagram, and after finding the transfer function we will get this. Now you have to understand the meaning of every term which is in the numerator and denominator. So here we all know S term, that comes from the Laplace transformation, and the two terms, one is omega n and another one is zeta. So omega n is termed as natural frequency and zeta is termed as damping factor of a second order system. So now I think you can understand the general form of second order system. Now the most important term of any second order system or any system, that is its characteristic equation. In this case the denominator part means s square plus 2 zeta omega ns plus omega n square is equal to 0. This is called the characteristic equation. Characteristic equation of this second order system. Now from here we can find out the values for the poles, means the values of s. So from here we can find the values of s, that is we can apply the quadratic equation formula. So that is minus b plus minus root over by 2a, that is 2 into 1 means 2. So it will come like by 2, sorry, I have divided that part with 2, so it will be the value of s. Now if we take the damped condition, means the value of zeta less than 1, in that case s will be minus zeta omega n plus minus j root over omega n square 1 minus zeta square. This can be written as minus zeta omega n plus minus j omega d. This omega d is equal to omega n root over 1 minus zeta square. This is the damped natural frequency. This is termed as damped natural frequency. Now, taking the step input means if we analyze the step response of this system, so we have to take input means Rs as step input. So what is the Laplace transformation of a step function? That is 1 by s. So if we understand the step response, then Cs will be Rs into this, means Rs will be 1 by s will be multiplied with this transfer function. So let us find the step response of this second order system. The step response of second order system, this analysis is most important and most common. In the examination you will find all the questions from step response, and in this same video I will discuss about the delay time, rise time, settling time, everything in case of step response of a second order system, and direct questions are being asked from this topic. So now, taking Rs is equal to 1 by s, Cs we are multiplying this, so now we can write it as omega n square into s. If we write it like s plus zeta omega n plus j omega d, s minus zeta omega n plus j omega d, you can write it like this. So now we can apply the partial fraction and then we can find the Cs, and from that if we find out the inverse Laplace transformation, we will find the Ct, which is the step response. So you can write it as a by s plus b by s plus zeta omega n plus j omega d plus c by s minus zeta omega n plus j omega d. So this will be minus, actually this will be plus, so here it is plus and it is minus. Now you can find out the Cs, and from that, taking the inverse Laplace transformation, you can find out the Ct. This is very long, so you don't have to do this. You can directly remember the Ct, means the step response Ct expression, and from that you can find different analysis. After partial fraction, you can find out this equation, which is actually the Ct, 1 minus e to the power minus zeta omega n t, natural frequency is omega n, by 1 minus root over 1 minus zeta square bracket 1 minus root over 1 minus zeta square cos omega d, it is damped natural frequency, plus zeta sin omega d t. Now let zeta is equal to r cos theta. Taking this, we can write Ct as 1 minus e to the power minus zeta omega n t by root over 1 minus zeta square sine, you know this transformation, omega n root over 1 minus zeta square t plus theta. You can write it like this. So this is the final formula. This is the final formula for the step response of a second order system. You always have to remember this, and from this direct questions will be asked. So here theta is nothing but tan inverse root over omega n square root over 1 minus zeta square pi zeta. This is the theta value, and this portion is actually omega t. So